If you're in business, whether you like it or not, you're involved in some way with either buying or selling. As a buyer, you're often competing with other buyers to buy a thing, which means you're like in an auction type situation. Like if you wanted to buy an oil field or something like that, there's only one of those things and everyone's bidding trying to buy it. And the high price bidder will win that auction. High bid wins you the auction, and that's good, but you don't want to overbid, right? You don't want to overpay for something. There's this trade-off between winning the auction and being smart about it. Now, selling can also be thought of as an auction. Most of the time, my students think of an auction as just like, buying something at Sotheby's or something like that, or on eBay. But a lot of times as a businessman, you're trying to sell something, right? So we might be bidding for a contract. We might be trying to sell our services to somebody. So we want to sell our product, but the buyer's probably shopping around trying to get the best deal possible. You win if you're the low-cost seller, but you also don't want to give the product away. You certainly wouldn't want to offer to sell, a bunch of computers to a university for $1. You'd go broke that way. So again, we have this trade-off between winning the auction and being smart about it. This idea that buyers overpay or sellers undercharge is something called the winner's curse in auctions theory. See, auctions are kind of complicated to think about. You not only have to figure out what you should do, but the best thing that you can do depends on what your opposition is going to do, and we don't know what our opposition is going to do. See, we control our own bids, but we have no control over our opponent's bids. And it turns out, though, and this is really neat, that you can make really smart business decisions without knowing precisely what your opposition is going to do, as long as you know vaguely, probabilistically, what your opposition is going to do. See, we can think of our opponent's bids as random variables that come from some distribution. As long as we can model that distribution somewhat correctly, we can make really smart, strategic business decisions. Let's see how it's done. So let's suppose that you're a cardboard box company, and you're trying to sell your boxes to this online retailer like Amazon or somebody like that. Now, if you win the auction, you've got to actually assemble the boxes and make them and ship them and all that. And so there's a cost involved to you, and let's just say that it's $185,000. If you don't win the auction, you don't have to make the boxes, you don't have to ship them. Your costs are zero, but your profits are also zero. So this is a low bidder type auction where we're trying to sell, and the person who offers to sell the boxes cheapest wins. But we don't want to sell so low that we don't make any profit. For example, if we offered $185,000 as our bid and we won it, we'd get $185,000 in cash, but we'd have to pay that to make the boxes, and our profits would be zero. And if we offered, something even, worse, so if we offered to sell at $100,000, great, we'd win the auction, we'd get $100,000 in cash, we'd have to pay $185,000 to build the boxes, we would lose $85,000. You're not going to stay in business for very long if you do that. So we need to kind of make that trade-off between winning the auction and making a profit. Now, for this simple example, let's treat our opponent's bids as being coming from a uniform distribution, something very simple. It's a rectangle with endpoints at 200,000 and 300,000. So today, if whatever bid we make, doesn't matter, our opponents are going to pick some random number between $200,000 and $300,000. That's going to be their bid. And hopefully we win without underselling ourselves. And then the question becomes, well, what should we bid? We can try a whole bunch of different prices, and simulate our way to an answer to figure out which bid gives us that best trade-off between winning the auction and making a profit. And we'll do that by looking at the expected profit from our bid. So let's see how that's done. Okay, so we've pulled up Excel and I've pre-populated it with the numbers 1 through 20,000 here, just so you don't have to see me scrolling down and typing 20,000 numbers in there. So I'm going to have a whole bunch of simulations, 20,000 of them, and I'd like to see how I do if my bid, so I'll just write here, my bid is $225,000. And then we can change this number later on. So we'll change that number and see if we can do better than a bid of 225. All right, so will we win our auction? Well, I need to know what my opponents are going to bid. So if the max bid by one of my opponents comes from this uniform distribution, then I can just use the rand between function and just draw a random number from that distribution. And we said that we believe that their bids are going to be between 200,000 and 300,000. So in this case, my opposition bid almost $300,000. That's a really high bid. So I think I would win that, right? Because I'm bidding 225. So let's just formalize that. Did I win? And every time I hit enter, I'm going to get a different random number here from my random number generator. So that's going to be kind of a moving target. But did I win in this case? I need a function here that will indicate, like, let's say a 1 if I win and a 0 otherwise. So we can use Excel's if function. And I know that I win if my bid is lower than the opponent's bid. So if this 225, which is in cell H1, and it's always going to be in H1, so I'm going to anchor it there with some dollar signs. If H1 is less than B2, and I'm not going to put dollar signs there because I'm going to try a whole bunch of different bids. I'm going to copy this formula and these numbers down, so I kind of need it to update. But my bid is not going to, I'm not going to update. It's always going to be in that cell. So again, I win if my bid is lower than the opponent's bid. So that's a 1. Otherwise, I lose and I get a 0. All right, so here, the opponent's bid 206. I bid 225. I'm no longer the low person, so I didn't win. But if we hit F9 and draw another random number, let's draw another random number. There we go. So they bid 274, I bid 225, so I win because I'm the low cost bidder. So I win. My revenues are going to be 225. It's going to cost me 185, and so that difference is the $40,000. So my formulas work. Now let's simulate 20,000 such scenarios. We double click and we get a whole bunch. And we can see that we won a bunch, we lost a few. We won a bunch, we lost a few. It looks like I'm winning a lot of my auctions. Oh, we can calculate how many. %1. And this is just the fraction of ones here out of that whole thing. Or in other words, the average of this column will give me the same thing. So it looks like with a bid of 225, I'm winning about 75% of my auctions. Now, what are my profits? Now, it's a whole bunch of 40,000s and zeros. What is my expected profit? It's the average of all of these profits. And it looks like my average profit, I'll put this in green now, is $29,800. Or thereabouts. If I draw a different random number, I'll get something slightly different. But it's in that ballpark of around $30,000. All right. So, okay. I think I understand now. If I bid 225, I can expect around $30,000 in revenues. But can I do better than that? Well, we can try a whole bunch of different bids here. We could try, 250,000, or we could try 260,000. Well, rather than keying it in by hand in that yellow cell, what we can do is just set up a table and have Excel do all this for us, a little data table. So we can try all kinds of values. We can try, let's say, 200,000. We can try 210,000 and 220. Oops. 210,000, 220,000, and so forth, all the way up to 300,000. And so we can have Excel plug in these values for us into this cell and give us an expected profit number. All we need to do here is just reference the final calculation that it wants. So that's cell H4. And we highlight this box and go to data, what if analysis, data table. It's going to construct this gray table for us. It's going to fill in these blanks here. So all of my inputs here, these different values, are in a column. So I need to tell it that they're in the column. I'm going to ignore this row input cell and just go into the column input cell. And then I need to tell it that each of the values in this column, I want Excel to treat it as though it was typing in a different bid, this thing that I'd highlighted in yellow. So that's all I need to do is right in this cell here, in this little pop-up window, is type H1. And it'll try 200,000 into here, 210,000 into there, and so forth. We click OK, and we see what happens. All right, so we get some numbers. Let's make them all look a little similar. Okay, so there we go. Now it's a little bit easier to read. So when I was bidding 225, I could expect around 30,000 in profit. But it turns out we can do better than that. A bid of 230, while it decreases my chances of winning the auction, I make a lot more money for the auctions I do win. And so that trade-off is in my favor. And it looks like the best is right there. At a bid of 240,000, that gives me the optimal trade-off between winning, which we want to do, but also making profits, which we also want to do, and those offset each other. So the optimal bet for us is 240,000, and that's a simple way of working your way through all of these possibilities for auctions. It's nice that we have this kind of framework to think about a complicated problem, and it only takes a few columns in Excel, so it's nice to do. Now, how can we increase the complexity? Probably the easiest way is to have a little bit more of a realistic idea of what our opposition is going to do. So this idea that our opposition is going to be some random number, but that it's uniform, was definitely a simplifying assumption, right? That we would just use a rand between. Maybe it looks more like a normal distribution. Maybe it's triangular. Maybe it's all kinds of different stuff. You can play around with different distributional assumptions, and your optimal bid will depend on what your opposition does. So your optimal bid will change. So if you're you're trying to think strategically in business about this kind of situation, you should spend a whole lot of time thinking about what it is that your opposition's bids could be, and try to assign them probabilities as well and as wisely as you can, because that'll be a really important factor into really getting very useful recommendations out of your program. Anyway, that's it for now. Thanks for your attention. Bye-bye.